Hi, I'm Justin Ryan. I'll be talking about DevOps philosophy and edge engineering in Netflix. Talk is relatively procedural. It's a peek behind the curtain, if you will. There's probably nothing you haven't seen before in some respect, but I put it all together and try and make a coherent story out of it all. If I raise some interesting points, great. Feel free to reach out in the Q&A afterwards or on Twitter and ask questions. When I say edge engineering, I'm talking about the cloud pieces that support the product that you possibly know. It's not the part where we stream the bits. That comes from the CDN. That's the big movie parts. I'm talking more about the UI pieces that you interact with. So this would be sign up, sign in, discovery, playback. Edge engineering is really the gateway into Netflix and for its 148 million customers. This presentation is a summary of what we practice, sort of in general. There are, of course, variations across our apps. It's hard to get, what would be 100 microservices on the edge all aligned. But these are sort of some of the best practices that we've sort of taken to over time. At Netflix's core, a team is responsible for having a service in production running. They have all the freedom they need to make it happen. The most common pattern is having the engineers that write the service also run it. If there were handoffs between a QA team or testing team, we'd sort of consider that a breakdown of the responsibility, right? If someone had the product to write and they got it out to another team, they've sort of lost the responsibility for keeping it up at that point. So in the end, we engineers are responsible for getting the applications out and actually keeping them up. And if we spend all our time just manually testing, updating dependencies, carefully watching deploys, we'd get nothing done. But before we could sort of talk about writing that code and getting it out, we started to just talk about keeping our systems up. It's sort of key that we can be able to walk away from our project for a little while and work on something else. So let's talk about some ways our systems can fail, and that will sort of lead into the pipelines that we need to keep them going. One would be infrastructure. This would be like the network's down, or we're on a bad VM, or a whole region has gone away. It could be downstream dependencies. So our service calls another service and their service is down. We could actually just make a bad code push. We wrote some code, we push it out, it's bad. That's on us. And of course at Netflix we have Chaos Monkey. In regards to infrastructure, we protect ourselves by running lots of homogeneous instances across many regions. So if we lose an instance, it can be replaced. If we lose a region, we can fail the region, go to another one. Same thing for Chaos Monkey. Losing an instance here or there is the same thing as infrastructure sort of going down. The problems we see in regards to downstream services fall into two categories. Either it's unreachable, and hopefully we have a fallback for that. But if we don't, there's nothing we can do about it. The other category of problems there would be it just being incompatible with that downstream. They've moved on to version 2 and we're still on version 1. That would be a problem. And then in regards to our own regressions, well, that's sort of fixed. We just won't do anything. That's sort of the point. What I was trying to explain here is that we really want these systems to hum along on their own without us. So we want to think about this as more of a dependencies problem, right? So maybe we didn't write code, but some other team has some change that we need. And that would be a dependency. They come in two forms. They could be too old, in which case maybe we're running an old client or we're using a library with an algorithm that's too old. And if we don't get that updated library or client, things aren't going to work. So we can't just use old libraries forever. On the other side of things, we have something that's too new, right? Someone released the library, it wasn't really tested, or it didn't meet everyone's expectations, let's say. So that sort of gives us the two sides of things, and it builds up a little bit of a spectrum or a little bit of a tightrope balancing act that we have to do. We can't have old dependencies forever, and we can't take the latest. So we want to be somewhere in the middle. We also don't want to babysit the process. We don't want to be in the habit of manually updating a version from 1.1 to 1.2. It's not a good use of our time. So we have this idea of a dependency train that moves forward. We use dynamic constraints and dependency locking. So for those who aren't familiar, We in Gradle can specify our dependencies in terms of a semantic versioning-like syntax or an Ivy-like constraint, like latest.release in our build files. Then there's a log file that actually captures the current state of what's been tested and what works. So then what we do is in isolation, we resolve those dependencies using those dynamic constraints, run the tests, and if they look good, we want to give them to master. So that's sort of how we're going to move our dependencies forward. As long as taking new dependencies, we run the tests. If they look good, we can commit it in. Tests are broken, that's too bad, but master's happy, production's happy, everybody's happy. So that gets us into our first pipeline and hence into Spinnaker. I should mention that we generally want a single dashboard for what's going on with our application. I can't be looking around a bunch of different tabs or different apps that show here's how it's running in prod, but here's how it built. We like to have these consolidated. So you're going to find me using pipelines in Spinnaker, even if it's just over a Jenkins job. In the case of the dependency pipeline, we run it every 6 hours. The goal is to get smaller chunks of dependencies flowing in. You don't want 50 dependencies to flow in, you want like 4 or 5 to flow in over time. That just keeps the granularity smaller, and our ability to fix a problem if it arises just gets better. The first part of the pipeline is to run a Jenkins job. It will do that Gradle task I referenced earlier, where it calculates the new dependencies, saves it to a log file. We also add on some scripting in there to calculate which dependencies have changed, so we can get a nice little textual diff that we can put into the Jenkins job or into an email. It also gets archived into a properties file, and this is important for Spinnaker. The way Spinnaker stages sort of interact with each other if you're using scripting or Jenkins are property files. They get loaded into sort of a shared context that moves through the pipeline. So you'll see that in a moment. That property file is then read into a preconditions stage. This essentially is checking to see if certain properties are true or false. And in this case, we're saying if the dependencies have changed. If the dependencies haven't changed, same old, just stop the pipeline and don't go anywhere. Otherwise, move on. And now we jump back into Jenkins, but in this case, we're going to actually run our tests. We're sort of decoupling the check for dependencies and tests, just to sort of keep this pipeline chugging away and not spending an hour running tests if that's what it takes. But this is the kind of place we'd run all our unit tests or integration tests, smoke tests, pretty much everything, all the coverage that we're trying to get out of this thing. And if it works, then we merge to master. That's sort of saying these dependencies are good, and we actually want to get this into master. This is a case where we're actually trying things out a little bit differently. Instead of using a Jenkins job to do the merge, we're using Titus. It's analogous to Kubernetes. It's essentially our Docker orchestration system we use at Netflix. It's open source, feel free to go look it up. With this flow, this dependency update flow, we can have an application going months with automated dependency updates. And it means all the teams that have libraries that need to get into our apps are happy. We're not spending time onto it. We're happy. We want the same kind of scrutiny on pull requests as we do one for dependencies. So we have a pipeline for it. The way we deal with this is we trigger on every push to a branch. So you might create a pull request, kick off a build. You might push on a few new additional commits, and that would also kick off a build. And so now in this pipeline, it's going to look a little bit similar. We first start off with a build in Jenkins that runs the tests and checks and everything else. On top of that, we then will run a quick little script that will call up to Bitbucket, Bitbucket server, aka Stash as it used to be called. That's what we sort of use for most of our internal Git hosting. And it just comments on the pull request. It's not a hard or fast requirement to have the build work. And I understand that that might be a little odd to some people. In the end, we ultimately want the developer in charge of what gets merged. For what we just assume that they have the most context around what needs to get out. Maybe they know by merging this, someone else's PR is going to get merged in too, and those together will fix the build. Likewise, we don't require a review. I mean, it's great when our team members review our pull requests, but we consider a pull pull request review a gift. And sometimes we're just busy and it's not giving season. And so we'd assume they're too busy. I can beg for a review or I can just sort of merge on my own and move on. The idea is in the end, I'm going to be responsible for running this. So the consequences of it not being good code will fall right back on me. We don't have to worry about there being a blame game or a handoff between other people. And then in the end, we actually use a check precondition stage just to make sure that the job worked, and if so, fail the pipeline. That just gives us a better view when we're looking at the Spinnaker pipeline and seeing what failed. So that's a pretty straightforward kind of pipeline. That gives us sort of two ways to get changes into master, right? Pull requests and dependency updates would be our primary ways. But we have to get those out, and that's what the master branch is for. This pipeline is triggered on every commit onto master. So it doesn't really matter where it comes from. If master changes, this build's going to sort of kick off. Same like the pull request, we're going to run a Jenkins job that runs our tests. You can sort of get a sense by this point that we prefer Jenkins when running our build tools like Gradle. But if it's a small little script, we might lean towards Titus/Kubernetes for that. If a build's looking good on master and we're trying to move forward, we then bake. Bake is the process of making a machine image in our app. In our case, it's taking a Debian file from the Gradle build and building an Amazon machine image. It's a little specific to us, that I get. It very well could be a Docker image. Spinnaker in the open source version has a bake stage that uses HashiCorp's Packer for baking. Same concept. The idea is you need to get a machine image. Once you have a machine image, you can deploy it. What we're going to do is actually put this into the test environment straight up. This now becomes the live build in test. At the very end, we then tag this image. Be it Docker or Amazon images, you can always tag machine images. This tag will sort of say, this is the latest tested image in test. And you'll see a reference to it later. A little side note. We run a relatively exhaustive set of smoke tests against a local running server. We use Gradle to instrument this. It gives us a lot of confidence about that when we push the test, it'll mostly work, right? The idea is we've already had a running server, we've run all the tests against it. If we put in a test, it should behave pretty much in the same exact way. And if it doesn't, then we can add a test to capture that in the future and prevent it from happening. A little particular to my team is how we write our smoke tests. We structure them in a way that we can run against a local server, like the Gradle task, or a remote server, which would then be run against a cluster. Maybe the cluster's in test or in prod. And this just starts to say, think if anything's a little bit fishy, we could say, hey, let's run that big regression test suite against this stack, or run it against prod to make sure everything's working the way we exactly think it is. Once the master build's done and it's running in test, we need a process to push this out to prod. We call this the Canary Pipeline. We run canaries when everyone's in the office. So Monday through Thursday, sometime in the morning. In this specific example, it says 9 a.m., but we move it around a little bit. It's just so there's not all happening at the same time. This pipeline is going to optimistically result in a deploy to production. And we don't want to deploy on Friday. If it wasn't obvious, Friday, Saturday, Sunday are sort of big days at Netflix. It's when people watch the movies, they watch the TV show. So we try and avoid pushing on a Friday. The first thing would be to go back and find that tag that we found earlier. You could also use a find image from cluster configuration in Spinnaker. This would sort of say, here's a cluster that's running, pick the image. We could do that also. That would also work. Then we go and look at prod and try and do a little comparison. If nothing is different, then no need to continue. That can easily happen if really nothing's been going out or nothing's been happening on master for a little while. And we don't want too much machinery to be running that doesn't need to. This is a case where that kind of comparison isn't trivial, so we have to write some scripts to make some API calls and do a little comparison. In the end, it's a bash script that we just sort of kick off. Like we said earlier, we have to sort of tie Spinnaker with the output of a previous stage. So we outputted a property file, and now we're sort of reading one of the values from the property file in a preconditioned state to know if we truly should move on or not. In this case, we are going to move We're going to extract out the build number. Build numbers are sort of the quickest way to get a pedigree of a deployment, right? If someone can just say, that's build 53, we could very quickly resolve that to what went into a specific build and then what might be affected. So we're going to sort of use a task here to pull it out, highlight it, and make it available later. It's done with an evaluate variable stage. So this is a Spinnaker stage that lets you write some EL expression language to quickly extract some value. It can get a little gnarly. It can get a little nested. We're sort of digging into a nested variable here. This is sort of an example of what we're doing here. But in the end, it does make it really simple from a Spinnaker point of view. You didn't have to write a bash script, check it in a repo. You can just sort of write the EL real quick. So then we get into canaries. In our case, we're using Kayenta, which is an open sourced canary tool from Netflix with some collaboration from Google. This is going to stand up two clusters, one running the production image, which is called baseline, and another one running the image under test called the canary. The reason for starting a baseline and a canary and running them together is to get very similar metrics. Ultimately, a canary is going to be a collection of metrics comparisons. And so we want these to be capture similar behavior, and jitting can be a big factor here. So if you're going to start up a fresh app, it's going to behave differently than an hour later. And so if we compared the canary to something running over in prod, the one in prod's already going to have everything jitted and behaving correctly. So we sort of want to stand these things up and have them behave similarly. And then we sort of track these differences. In our case, we're going to run this for about 4 hours, capturing a report. This is like a comparison of the metrics every 30 minutes. It's a little bit on the long side of things. We probably don't have to run that long. I think it's a little legacy. It sort of comes from when we used to run monoliths that would run maybe a fraction of the number of requests a second and do a lot of different things. So it's sort of a heterogeneous amount of requests, and it's not getting many through a second, and the metrics wouldn't really line up. So it took hours to really get a nice comparison. But these days, we have microservices that are running 10 times as much traffic through them, and they're much more homogeneous, right? They're dealing with one endpoint, maybe two. And so we do get a signal earlier. But 4 hours also gives us a sense of if something fishy is going on, maybe someone other than us might pick up on it. Which brings me to some aspects of canaries. In general, canaries are safe because of retrying, right? If a device gets an error, it will just retry and it will be fine. This can be a little limiting. It hides a category of problems. So for example, let's think that the server has given an answer and it thinks it's perfectly okay, HTTP 200. The device gets it, it rejects it, doesn't like it, and it tries again. So an example would be a DRM license. All the content at Netflix has DRM on it. We might think the license that we're giving to them is fine, but when you get to the device rejects it. It, cryptographically not kosher. Who knows? Our canary doesn't see a problem because it thought the response was fine. The user doesn't experience a problem because we're doing retries. And essentially no one is wiser to a looming problem that's just lurking out there. We might see like a slight increase in requests from the retries, but at our scale, we're just never going to pick up on something like that. We have some capabilities for sticky canaries. This is where we take the same user and send them to the same instances. There are some downsides because what we're essentially saying that there is some adverse behavior the customer might experience, and that's something we want to avoid when possible. So to do a system like that, we need to be able to monitor the user's experience in real time and stop the experiment or the canary as soon as possible. Like if there's any signs of badness going on here, we have to stop it. And getting it to stop within a few minutes is what makes sort of sticky canaries a hard thing to get right. So we do it for a few apps and we're hoping to increase adoption over time. So continuing on with the canarying, we eventually get a report out of it. If the canary gets a low score, a very low score, it will cancel itself. If the score is good, it will continue on over those 4 hours and get here. And what we do is essentially say, did it work or not? This works like an assert. So the check we do is say, did it fail? If it failed, fail the pipeline. Or I guess better said, if it succeeded, assert that it succeeded. If it didn't, fail the rest of the pipeline. But what we end up doing here actually is jumping to a manual judgment stage. This lets a person get involved. So let's say the Canary scores are really low. We might still want to go forward. We might have some understanding about the changes. You might say, hey, this instance is getting 10 times as much traffic through it. Fail the Canary. That seems wrong. But maybe someone made a huge performance improvement, and they're okay with this. So we want to make sure that there's a manual step in there for failures. We also keep the manual step in here during the early parts of an app. When an app is first being developed and just getting out to prod, we want to give it some extra checks on it. And then over time, we'll change the defaults to sort of just go on automatically, right? So let's assume the Canary is successful. It will just go all the way through to the endpoint. And this is where we actually run our deployment. Now, in this case, we're actually going to run it as a separate pipeline. This is so we can run it manually, the deployment pipeline in a pinch. Or it's also to keep the pipelines a little more manageable. You can already see that the line of this pipeline is getting a little bit long, and we want to make sure we can reason about the pipeline. So now we're actually talking about deployments. So let's start looking at this. It's made up of one stage for each region. So in this example, we're publishing to 3 different regions, and each one has its own stage. A side note, let's talk a little bit about time windows here, execution windows. The trick is to not do the push all at the same time. So we use execution windows to keep the push during a lull in traffic, but also do it when people are in the office, but also do it so they're not all doing it at the same time. So what we do is we create little slices of time that each one is allowed to push in. So it keeps them exclusive. It's not the most efficient, we understand that. And we can always manually skip the remaining window if we want to. We're sort of hoping for Spinnaker to sort of solve this on their own, and then we can come back later. We could have done something more complicated, but we're definitely leaning towards simplicity here. I wanted to make one side comment about these pipelines. We've been iterating on these pipelines for a long time, years. And we've done all sorts of stuff. We'd Canary before deploying to test. We do dependency updates every hour. We'd auto merge a pull request if a single person approved it. We've gone through a bunch. In the end, we found that the simplest pipelines are the best pipelines. We'd rather these things flowing on a regular basis and having everyone understand them more than anything. There are other pipelines that we have going on here. There are developer Canary pipelines. So this is very similar to what you saw earlier, but it's going to be built based on a developer build. So a developer could say, here's a branch, build it, Canary it, tell me the results. There are going to be some scenarios that we need live data to know if our process is working or if there's any edge cases we've missed. So this is a very useful pipeline. We also use Spinnaker and some pipelines for administrative kind of purposes. In this case, if we find an auto-scaling group that's been disabled, we're going to remove it, delete it over time. So part of our deployment process is to do a red-black. So you have an existing cluster, you push out a new one, you send traffic to it, and you disable this cluster. It's still running, leave it around, and then after a certain amount of time, let's say 48 hours or 24 hours, this reap disabled ASG's job will come through and remove that disabled ASG. So it keeps our costs down, but also gives us this cluster that we can fall back to. We also need to sync stacks. So there is a stack of instances that we run in the test environment that we want to look like prod. So we use a Spinnaker pipeline. We say, go look what's in prod and copy it over to the test environment in this stack. And it keeps things in sync. So with all those pipelines, we don't have to do anything. These things will chug along and keep these apps running. I think you'd easily see us going work on one app and leave 7 apps alone for months at a time if necessary. It lets us go on vacations. It lets us go home on the weekends and feel good about it. It's what gives us a lot of confidence. For those astute observers, you might have seen the word MEME, this is M-E-M-E, on the pipelines. So this stands for a managed experience for most of Edge. The idea being we've encoded the most common practices into a bunch of tooling, and then we apply it across a bunch of applications. It's very easy to get pipelines across dozens of applications out of sync. And so we have some internal tooling that synchronizes the pipelines across many apps. It's not something we've open sourced yet. It's very, very opinionated to what we do in Edge. It's not even like all of Netflix. It's just our org. In the end, having the same pipelines across all your apps is very important. So thanks for listening. I hope that was helpful for everybody and informative. Feel free to reach out during the Q&A or ask questions on Twitter. Okay, bye.